So we are studying chapter number 14, chemical kinetics, and in previous video I showed you that we are going to solve this question in this video. So here we have question that appearance of ammonia is reported, and then we have to find out what is the rate of the reaction, rate of disappearance of nitrogen, and rate of disappearance of hydrogen. So let's start to solve this question. So first we have to write down the rate relationship between each reactant and product. So we can write like rate of the reaction will be equal to rate of disappearance of N2 will be equal to 1 over 3 rate of disappearance of H2 and 1 over 2 rate of appearance of ammonia. So in this case we have to establish the rate of appearance of ammonia and reaction rate. So basically we have to find out reaction rate, but ammonia appearance rate is already given, and the relationship between these two will be equal to like 1 over 2 rate of appearance of ammonia, based on the coefficient will go into denominator place. So we can write 1 over 2 1.15 molarity per second, which is rate of appearance of ammonia given in the question. Once you divide this one, you will get the answer 0.575 molarity per second. So this is the first answer for the rate of reaction. Next is they are asking the rate of disappearance of ammonia. So if you see from here, they are asking rate of disappearance of nitrogen gas. So the relationship between the rate of reaction and rate of disappearance is equal without any fraction, because there is coefficient is 1. So we can write that the rate we have calculated for this reaction from the first answer is 0.575 molarity per second, which will be equal to the rate of disappearance of ammonia. So this is simple. The third one is they are asking the rate for the disappearance of hydrogen gas. So this is the relationship which we can draw from the first rate of reaction will be equal to 1 over 3 rate of disappearance of hydrogen. So what we can do here, we can multiply the whole reaction formula by 3. So this will become 3 rate, 3 times of rate, and here 3 will be cancelled. So now we can say that rate of disappearance of hydrogen will be equal to 3 times of the rate of reaction. So we can write 3 times of rate of reaction, which will be equal to 1.73 molarity per second, and that will be the third answer for rate of disappearance of hydrogen. So this was the example for how to calculate the stoichiometry from the rate of reactions. And another question was this one, that N2O5 decomposition was given, and here in this question at a particular, so decomposition of N2O5 at a particular instance is reaction vessel is 4.2 times 10⁻⁷ molarity per second. So N2O5 disappearance is given rate, and the rate of NO2 and oxygen we have to find out. So how we'll calculate this? So we'll write first reaction, make sure balance, and we have to find out the relationship between each. So rate of reaction will be equal to 1 over 2 rate of disappearance of N2O5, that will be equal to 1 over 4 rate of appearance of NO2, and that will be equal to rate of appearance of O2 without any fraction, or because there is coefficient 1. So next is first they are asking the rate of appearance of NO2. So we have to establish a reaction relationship. We can draw from here that rate of disappearance of N2O5 is 1 over 2 rate of disappearance of N2O5 will be equal to 1 over 4 rate of appearance of NO2. So here I rewrite the same thing in just opposite direction. I write rate of appearance of NO2 first, which is 1 over 4, will be equal to 1 over 2 rate of disappearance of into 5. Then we have to move all the numbers on the right hand side. So what I have to do, I multiply both side by 4. So this will become 4 by 4, 4 cancel, only 1 will remain, and here this 1 over 2 will become 4 over 2. So 2 multiplied by 2, 2 times 2, 4. So this will become 2 times of rate of disappearance of N2O5, which is 4.2 times 10 to the minus 7 molarity per second multiplied by 2. So then you can calculate rate of appearance of NO2 will be equal to 8.4 times 10 to the minus 7 molarity per second. The next one is they asking the rate of appearance of oxygen. So from the first we can draw the relationship between the 1 over 2 rate of disappearance of N2O5 is equal to rate of appearance of oxygen. So we can rewrite this equation in this form, that rate of appearance of oxygen will be equal to 1 over 2 rate of disappearance of N2O5. So whatever the rate of disappearance of N2O5 is there, it will be half of this one. So 1 over 2 multiplied by 4.2 times 10 to the minus 7. Once you will divide, you will get the answer 2.1 times 10 to the minus 7 molarity per second. So these are the two examples. You can review some more examples for stoichiometry and how to calculate the rate.